Hello guys, welcome back to my channel, and in this video we will talk about my KS0-PRO solar setup. So as you can see, the three of these miners running on the solar only. Right now obviously I have the backup hooked up to this my server PSU, just in case there is a rainy day and I don't have enough juice, so it will kick in after the battery discharged to 12.6 volt, I believe. So this is a 12 volt setup, so keep in mind this is direct mining from the battery. So the battery, as you can tell right now, it's 13 volts, and it could drop all the way to 12 and a half before I'll start, recharging with the power supply. And usually overnight it stays pretty well until the sun comes up. I'll show you some more information. I just want to show you setup here. So as you can see, I have the SmartSolar Victron SmartSolar charge controller, which is 250-100. The first number represents the 250 volts input from a solar array maximum. So I can connect in series bunch of panels, so I can avoid running a large wire. See, it's only like I have 8 gauge wire here, but I could do the 10 gauge. Maybe it is 10 gauge, so you don't even need to have only running 10 amp maximum on this wire, because they're all in the series and they supplying 100 amp of charging power. So this 100 amp going to the battery at 12 volt. So I'm converting from like 150 right now volts to actually 130 volts with about 9 amp, and that gives me 100 amp total rate for the 12 volts, because 1200 watts or 1300 watts maximum. I did go when the battery voltage higher, it went like to 14, almost 100 watts, right? So you could see there is a fan at the bottom. Like you would ask, like, hey, what's this fan doing here? So now, just to be honest, guys, it's the system set up in garage, and you saw the temperatures in garage right now, 92 degrees. And we'll talk about temperatures even more for overclocks for this KS0-PROs, because it's a really important part is the ambient temperature. Now you could see this is a larger fan on the special edition one, on the green version, and these two are the black KS0-PRO, but I still have the 1500 RPM fans, and this one is 6000 RPM fans controlled by this little device with the temperature sensor controller. So what it does, if the ambient temperature goes up, the fan runs faster. Obviously, when it's cooler at night, the fan could drop into 1200 RPM when it's not necessary to run full speed. So you could adjust and do your own temperature setup, which is nice. And I have all the links in my Discord shopping channel there. You could just click and see all the hardware that I have purchased over there, so you can look through and see if you like any of that stuff. So now going forward, let's talk about solar a little bit more. So this fan will kick in. There is a little input here which is relay. So this solar charge controller has relay, and I programmed that in Victron app, which is really cool app. I program it to turn on only when the sun comes up. So anytime we have sun, this fan will kick in and it will run. This relay will turn the power to this device. It's basically as a switch. It's a relay up to probably 10 amp, so I don't need to use that 10 amp. For this fan, it's only maybe a couple 1 amp, if it is, maybe less, half an amp. But what it does, it helps, so when it's running the air from bottom to top, because this heatsink gets super hot when you're pushing 100 amp through it to charge, and these wires get super hot, and the whole heatsink is just like you can't even touch. So when it overheats, actually it reduces automatically the amperage, so it will not go to full 100 amp. It will probably reduce to 90 or 85, But if I have this fan running, which only uses slight energy, right, only like maybe 5 watts, it will run at the full capacity this solar smart controller, right? So, smart solar charger. Now it will shut down at night as soon as the sun goes down, so I'm basically not wasting the energy much from the battery. It's only when the sun comes up, which makes sense. Then the solar, only when it's working, it's heating up, so I need to cool down. So it's kind of cool feature that Victron has. If you have questions about it, let me know. I'll can guide you through how to set it up. It's very cool, but it's not available in all of the Victron charger. Like this one doesn't have relay. I have another one like 150 by 50 or 100 by 50, and this one doesn't have relay. It's only have communication ports. See, like right here and right here, and it's communicated with the Cerbo-GX. This Cerbo-GX hooked up to the internet. You can set it up as the wireless or set it up as the network with the Ethernet cable, which is a lot better, obviously. And you hook up power to it. That's all it is. It uses a little bit of energy, obviously, probably like 2-3 watts, I want to say. So you have to keep in mind the power consumption of all of these devices. So now, solar charge controller doesn't really use the energy when it's not, when there is no sun. Probably uses maybe 1 or 2 watts, very, very minimum. When the sun comes up and it starts charging the battery, it uses probably 5 to 10 watts. So, well, plus conversion of the, basically it heats up, so it does work that way. All right, sorry about that. Where were we? Okay, so yeah, about the smart chargers, the smart solar charge controller. Victron has many different kinds. You could see that this one is 115 amp charge, 100 volt input. This is 7515. Those are my old that I use in the car. I actually have a battery right on top of my car, rocks, and it charges the battery in my truck. So it's pretty cool, and I could use for power tools. So now this is a little step up, and this is the highest. It's pretty expensive. I think it's like around $500 to $600. But it does a lot of interesting stuff. So first of all, it charges the battery to the full capacity because it has a 100 amp load at the battery. So it makes a 1.2 kilowatt or even up to 1.4 kilowatts when it's 14 volt, goes close to 14 volts, right, of the solar charging. So, and this guy is 50 amps, so this could do about 600 watts to maybe 700 watts. So now just to compare, so it's almost half of it, and the price on that you cannot see, but it's looking similar, just a little smaller, and it doesn't have that relay. So that's what fan for, basically, to cool down and use full capacity. If you would ask, like, why do I have this? I know it's look a little ugly. I had to tape it down. I have to figure maybe some kind of brackets there, 2 little angle brackets, and screw it down to the plywood here and just make it more look appealing. But right now it works. So all I need just to cool it down and not wasted battery at night, because at first I could just hook it up and it would run all time, which I don't need at night, this fan running, right? And I have similar fan there. There's a, you can't see this little piece, but this is a charger, 12 volt charger that I hooked up directly to my server PSU. So from server PSU, it's hooked up to this charger, 12 volt to 12 volt charger, and it will kick in if my battery goes to the low, but when there is no sun, obviously. But with the sun, I am totally finally actually makes this work to the point where it's actually doing pretty good. I mean, oh, from this angle I can show you guys. Oh, I didn't see that. All right, so this is the second charge controller, just right there. So the first one, this is the 150 amp, 100 input, 50 amp load, and this my solar KS0-PROs hashing away from sun. Isn't it cool, guys? It's just hashing the sun away. This blue light and all that. This green one looks pretty cool. So let's talk slightly more about the temperature, ambient temperature. When it was like in winter, yeah, we didn't have enough solar, but temperature in garage I had like around 78 max during the day, and like dropping to probably 65 at night or 70 at night, right? Because I have a bunch of this Octominer running. So now, because it went today to almost 94 here, and at my rigs there at almost to 96 degrees, so that's makes it super hot on the intake ambient temperature. Obviously the fan running like was running full speed. Right now it dropped already, you could see it's 153, but when it gets even hotter, this runs like to 163 watts. So this wattage is including the fan, and this one is only 147 watt, just to compare, because this is a 1500 rpm fan on this one, and this one 1500 rpm, and my only special edition, the green ASIC, has the 6000 rpm fan controlled by this fan controller, speed controller with the temperature sensor. So you could see the temperature slightly dropping, and so the fan speed, and so the power use. So during the day when it's hot, it uses slightly more power, so you have to account for all these little details when you create solar. So now let's talk about what do I have. I have 4 of these massive battery 200 amp hour batteries to run this 3 KS0-PRO overclocked, and it's pretty much to the limit. I can't, it's a 10 kilowatt hours roughly, right? This whole setup of the battery, slightly more, but my 3 KS0-PRO using 10 kilowatt of hour a day. So there is a little extra, because during the solar it uses solar power for a minimum of 5 hours, and it charges the batteries. So I only need like 18, maybe 19, 18, even less, 17 hours to run on the battery, and so I don't need the full capacity. But I'd like to use maximum lifespan of this batteries is actually 15 years if I gonna use 80%. So if I set it up and let it run, it will run for 15 years non-stop, as long as I have sun, obviously, but it will charge and discharge automatically every time, and especially during the sunny period like when we have right now. And so from the April probably all the way to November, I would want to say maybe October, November, we're gonna have full sun, and then just in the winter months when electricity cost is actually a lot less expensive, it will kick in when we don't have enough sun, that it will kick in, this power supply automatically kicks in. And how it's done, it also controlled by this Cerbo-GX. So the Cerbo-GX has the 2 relay controllers, right? And what I did, I hooked up and set the battery voltage to when it's roughly to 20% discharge, right? And it will kick and turn at 20% this server PSU, and it will start charging and supply the power. It basically not really charging the battery, will supply full power only for this guy. So I'm not wasting more energy, I'm just only running this guys, which is like 450 watts of power right now, and it's all on a solar. So it's crazy. It's a 10 kilowatt, 10.8. I'll show you some data right there. Give me a second, let me open them. Okay, you probably saw this from my previous video. This is Victron Energy dashboard. So basically when you have Cerbo-GX installed, or there is another couple more things that they have that have this ability to connect to the Ethernet or network, right? And then you connect to anywhere in the world basically to see this data. So right now it's around 5 p.m. and you can see I'm still totally fine mining on the solar and even charging a little bit. So There's a little bit less power right here. It was cloudy, few clouds there, so you could see like this is forecasted total 10.5 kilowatt. I already did 9.7 kilowatt today. I think it will be another maybe 3/4 of kilowatts. So probably I'll get to 10.5. I'm pretty sure I'm gonna get to 10.5, but I'll preview that. I'll show you. And I used forecasted is 10.7 kilowatt that I'm gonna use based on my usage. It's like I'm using 440 watts every hour, right? So that's what my usage here, and it shows right there. It shows a little bit more because of the usage of the fans, and then I'll blow in on the probably 5 watts there on Victron, that charge controller, and also charge controller uses a little bit, like maybe 5 watts each. So it's kind of adds up a little bit. When it's actually only on the battery, this drops down a little bit, okay? Just to give you guys idea. So this is the setup. Let's take a look at some data here. So today, this is to date. You can actually scroll down to yesterday and see what we had yesterday. Now I can use this data and see how I can adjust my charging for the battery, right? So my consumption is pretty close to 10.7 kilowatt every day. I got 11 kilowatt of solar, so I got an extra 300 watts of solar, right? So I had a capacity in the battery to 96. Actually, I want to keep it down probably to 90. So I need to work through the settings and kind of try to adjust so it will stop charging less there, and I will discharge a little more. See, like I'm discharging to only 35%, which is also kind of cool for the battery. But I want to keep my upper charging not to 96, 97, but kind of more to 80, like, you know, how Tesla charging between 20 and 80, like your sweet spot. So that's where I want to find that kind of sweet spot. And look at the day before yesterday. Consumption 10.9, 10.6 solar. So, but still was able to get 96% battery and discharge to 40% from before date. And let's take a look on another date. See right here, when we didn't have enough sun, that's where the charger kicked in. So it didn't show that I use energy because it was on the server PSU. So I used oh no, this is actually when I got my force battery. Sorry about that. So I was resetting the battery, charging it, and hooking up my number 4, because I have only 3 batteries and it wasn't enough. Show you previous dates, because the 3 battery at night didn't have enough power juice, even though I would charge it to almost 100%, and then it will not have enough energy from 3 battery to run those 3 KS0-PRO. So you could see where the where the server PSU had to kick in. And I have less solar. We have some rainy days last week. So when it was like a lot more sun, let's say here, like, yeah, 8.3 kilowatts, and I had to add 2 more panels just to get to 10 kilowatts. So it is, I had to do slight upgrade with my the CERT KS0-PRO, that green special edition, and it used more energy. So at first I thought I have enough, even extra, but with the third one I start running out of power a little bit. So with the few upgrades now, I am pretty happy with the data. What do you guys think? I don't know if you're running on solar. How do you set your battery? It would be interesting to see how do you set your minimum maximums if you're using Victron. Now for this specific setup, I'm not using any. If you noticed, there is nothing for inverter. So I didn't even hooked up inverter, because inverters using another up to 30 watts of power, and some inverter actually even more, like up to 100 watts. That almost running an extra KS0-PRO on the stock firmware, right? So just doesn't make any sense to run inverter, and then you're gonna lose another 20% converting from 120 volts back to 12 volts or 19 volts. So it will be so much wasted energy. And because KS0-PRO can run at 12 volt, and look at the amperage here, there is 12 amp and 11 amp. So you could see that the power kicked in, the fans kicked in here, and it's running using more power right there. So about 1 amp extra almost, right? So you could tell by how much load you put in on your KS0-PROs, and especially for this one, I actually already soldered directly to the board the power supply for the with the XT60 connector. And this one, you could see I'm still using this cable. Yes, it's still using this barrel connector, which is not safe. But again, if it fails, I'm gonna just solder directly to the board, so I'm not really too worried about it. I have separate video coming up on the on my 7 mining box. My connectors start burning away when it came up, to 96 degree hotter. So the ambient temperature is really important, guys. So if you are in a hotter environment, you have to watch out, because this KS0-PRO, I'll show you, it's running a lot warmer today than any other time. When it was cooler, it was actually super cool. So look at number 8. So this one with the heat sinks, but 1500 RPM fan, so you could see the temperature's kind slightly higher, and look at this one. This one is the number 9, have no heat sinks on the MOSFETs, and you can tell right away, even though the overclocks are lower. This is 280. I don't know if I can put next to each other. So take a look. This is the 300 gigahash. This is 280 gigahash. And look at the temperatures, guys. So this with the heat sinks, it actually runs cooler on 300 than this without heat sinks, obviously, on the 280 version. Which 280, technically, you can run without heat sinks. But if I install heat sinks, this temperature will drop below these, so it will be even cooler. Look at the temp. Or if I put the fans, instead of this two runs on the 1400 RPM, 1500 RPM fans, I think it's not enough airflow even using the Fruition Design kit. You have to use the, I'll put those 6000 RPM with the controller, because I don't want to run them at 6000 RPM. You probably need like maybe up to 3000, but when it gets hotter than 90 degrees, I think it needs to go towards like 35 to 4000 RPM or even more. So be really aware of where you're mining, what temperatures you're mining with. And look at this one running with this temperature controller, which automatically adjusts speed, and beautiful 300 gigahash, all the temps. That's how I want to see them, all below 60 here. This one, I really like to see this even below 50, but that's totally fine with the ambient temperature being 39 degree, right? So when it drops down at night to, in the garage, to 80 or even 75, it will be, these temps will drop a little bit, but the fan speed will drop also by a lot. So it will be, let's say, like to 1200 RPM, and it will maintain this board temperature actually around 50 degree, where if you run in these guys for 1500 RPM only, it will actually drop temperature at night cooler, much cooler. So it will go hotter at day, so it will go like to your 60, like right here, right, 66. And then during the day, you will see temperature going to, during the night, you will see like 50. So that's not very ideal. That's why I like to use this temperature sensor, and I do recommend that, because if you changing the temperature a lot on the chips back and forth, day and night, what happening is you causing the hotter temperature and then cooler temperature at night. So you'll causing that board and all the parts and all the MOSFETs going expanding and contracting at night, and then expanding. So every single day you will have more of expansion. So you want to keep this number of the board, not the in temperature you can't control unless you have AC, right? Unless you're running in, it's ideal probably running inside the house with the AC, or like when it's always 75 or 70, right? But it's not always possible, so at least we can control out the chips and this temperature board out. on the MOSFETs were to be more stable, so we don't want to jump too high, like to 70 and then drop to 40, right? So if we are within like 50-degree range, like 45 to 55, so more or less like only 10 degrees jumps, it's probably ideal to keep as close as possible to that change, not to run like 30 degrees or 40 degrees difference between night and day, because it will actually probably damage your miner faster, in my opinion. So anyways, let me know what you guys think about setup. If you have any questions, if you are mining on the solar, I'd like to know what your setup look like and how many batteries you use, what the capacity, sorry about that, capacity of your batteries. Like I have 200 amp hour, 4 of these batteries running, just 3. If you don't overclock to 300 but only to 250, I believe, or 260, you can run potentially 3 of them on the 3 battery, and also you need per each about 3 solar panel 200 watts, so roughly around 600 watts. So if you put 3 of them on 250, you probably safely can mine day and night, 24 hours with just 3 battery. The reason I did 4, because I do want to overclock them to where I can and to use extra energy when it's possible, and I have extra battery actually capacity, because I don't want to use all 100%. So since I'm using 80% of a battery, so technically I'm only going to use 8 kilowatts hour of these batteries, and therefore is this is my batteries right there. They're kind of big, but not too big. If you look at it, it just you know, takes a little corner there, and the setup for solar. So mainly you need to find the place for your solar panels where I put it on the roof, and that's pretty much it. Let me know if you guys like it or not, or how you do it, how would you do it, and if you're running through the inverters or not. I've seen other videos, the guys just doing the inverters, obviously, because you're using for other power use, which I may add inverter just for if I want to use like for in summertime, maximize capacity. But I like to keep this solar, guys. I mean, especially this green edition, really mining on the solar for me, because it's already green, right? So makes sense to make it a solar mining machine. Anyways, that's pretty much it for this video. I hope you like it.